So let's start. So in the previous session, we have done something about it was mostly about FEA and your meshing. So now we will be doing some examples in hands-on session. So let's try to do this. Yeah. So the first example we will be doing of a beam. It's two examples will be there. One with the rectangular cross section, and another will be uh, circular cross section. And the lengths and dimensions are like these. And we will be having, we will do this problem having different boundary conditions and different load conditions, different boundary condition. For example, the first case can be what? This is the fixed beam, cantilever sort of cantilever beam. So we can have the cantilever beam, the one end fixed and one end free, and then we will see what are the results, what are the deflections, and in some case we can have this simply supported beam, and in some cases we can have point load, and in some cases we can have what? Uniformly distributed load, and we will see that how we can what how the results are, what results are we getting. Okay, so let's start with this. Yeah, if you any one of you is having the system, the ANSYS software installed, you can do the hands-on along with me, along with me. So first of all, we are going to do static structural analysis. So what we are going to do is we just select one module of static structure. You can just double tap and it will appear here. Okay, so let's first of all we select the material. We will check it first for the structural steel and one for journal material. Let's say some other material we can take. uh, let's say some poultry, let's say take polyethylene. uh, Polyethylene. Okay, now the we have selected two materials, polyethylene and structural steel. Now, what we do is first we create the geometry. I will show you how to create geometries in the design modeler. So in the first session, we have done this thing to create geometry, to create a beam, But this time I will be using some different method. Okay, uh, and we will see what is the difference. So one way is to just take one-dimensional element, because if you see the dimensions are the length, longitudinal dimension is very large as compared to what your cross-sectional dimension. So we can treat this structure as a line element, So we are going to first we see we will take this as a line element, and then in the second case we will be taking this as your three dimensional structure. Okay, three-dimensional structure. So let's start. Where were we? Yeah, now first of all you change your units. I'm working in millimeters, so that's okay. You can do in whatever units you like. Now go on to sketching. First of all, turn on the grids. And yeah, some parameters is to be needed to be set. Okay. Now the grid is on, and now I can draw a line of length. How much? As I am going to treat this as a line element, so I am going to this as a just I'm going to draw a line only, okay, and I will specify its dimension. By default it is 50 mm, so I am going to take it 1000. The length of my beam is 1000 units. So yeah, that's it. So okay, now I will generate the sketch. The sketch has been generated, so it's just a line element I have taken. Okay, now what you can see is you click here load कर दीजिए इसका. So you can see the yellow line that we have drawn of unit 1000 mm, 1000 mm. Now what we haven't done is we haven't defined the cross section of this beam. So it's a line element. What I am going to do is, first of all, I will define the cross section, and in cross section I have some options. Yeah, from here. So I want rectangular cross section. Yes, for in first case I want rectangular cross section. So I will select the rectangular cross section, and it is asking width and height of the cross section. So I am giving it how much? What were the dimensions? 40 mm and 40 mm. So no 400, it's 40. Okay. Now I have defined a cross section. Now I want to apply this cross section to my sketch. I want this cross section that I have defined here. I want this cross section to in this sketch that I have drawn 1000 mm. Okay. So lines, select, go to the concepts, and here from here you can create lines from the sketches. Yeah, so base object is my sketch 1, applied. Yeah. Now I have created a line object. You can see this line object is showing. Okay, now in here you can see it is asking from the cross section of this line body. So I have already created a cross section. I will select this cross section and apply it here. I apply it here. So when you click, it will already detect that what sort of cross sections you have defined in this project. So when you select this, you can now see that this line body has been generated. Now, if you see this thing, you cannot see, you just see a line. But when you go to the view and you just click onto the cross-sectional solids, so you can now see that we have this cross-section of the cross-section is visible now. The whole beam is visible now. Now, your geometry is complete. And we go to what? Your modeling part. Your geometry has been completed. Then it will import your geometry, and open up it in the mm, modeling part. So the geometry has been imported. You can see that this is here again showing only line. Okay, it is showing only line. So what we can do is we can just go to the view and show what cross-sectional solid. So when you open this, you will be able to see the cross-sectional solid. Okay, so why I am doing this, main purpose here is to show that how and where we can apply the 1D, one-dimensional meshing. My main purpose here is the one-dimensional meshing. So you can here see the geometry part, line body, and by default it has selected structural steel. You can change it to some other material like polyethylene. So let's go on to the meshing. We just go and generate the mesh. We can see it has generated the mesh. So if you see, let's say, turn off the cross-sectional solid, turn off the cross-sectional solid view. So it is showing you the simple. You are going to have one element along the length, if you want to refine your geometry, if you want to refine your mesh, you can go to the sizing. And here your sizing of the element can be what, let's say I put it to 10 mm. Okay, and I think the units is in meter, so 0.01 mm. Now I can generate the mesh again. So here you have the what, your meshing has been refined, but you can see the meshing in here is the elements is divided, or the meshing has been done along the longitudinal axis only, because we have taken the line element only. So this is your 1D element in meshing. This is how your 1D element in meshing works actually. So we proceed further, and after this we have meshed it down. Now we can apply what, this is our beam, and now I want this beam to be statically structural. So again I have to turn on the view of the cross-sectional solid, otherwise I won't be able to see clearly. So first of all, I have to define the supports. So let's say I want fixed support on the one end. So it will not detect, it will just detect the point. Okay, line element, so either it will detect line or the points. Okay, now you have this edge fixed and you want to apply a load on the other end. Now apply the load here. Let's say you want to apply a force. Where you want to apply the force? Here, over here. Select this point and apply the force. You have defined where your load, you want to act your load, and now it is asking what magnitude of load you want to apply on this particular beam. What magnitude of load you apply? So let's say I want to apply the vertically downward load on this point. So you can see the Cartesian coordinate, positive y-axis is the vertical one. So I have to apply the negative y direction. So let's say I want to apply 1 kilonewton load minus 1000 Newton. I have applied. Now my load has been applied and you can see the direction. you can see the direction of this load that is acting downwards, okay. Now ये तो हो गई आपकी, दिस इज ऑल अबाउट योर बाउंड्री कंडीशन एंड लोडिंग कंडीशन ऑफ द बीम. नाउ यू कैन जस्ट डू व्हाट, you want some results, you want what, you want deformation, so you want total deformation or directional deformation. Okay, no, I want just what, total deformation. ठीक है, so it will now show you, it will calculate the total deformation of your geometry. Okay, now go on to the select solve this problem, and it will be solved very easily. So you can see your solution has been done. Here, over here, you can see the minimum deflection, that is 0. Obviously, the fixed end is here, so fixed end doesn't move. So the minimum deflection is 0, and the maximum deflection, you can see it is showing 7.8 mm. So this is how your beam is working. You can simulate your beam. If you want, you can change the different type of loads over the surface, uniformly distributed load, and some other things. So this one is just basically your 1D element. Now we are going to, this is your line geometry. Okay, we have done this problem using line geometry. Now we are going to do the same problem in 3 dimension. Okay, we are going to do the same problem in 3 dimension. Okay, 3D geometry create करके we will be creating the 3D geometry and solving the problem with the same load and boundary condition, Okay, so let's click on to the what, your static structural. Yeah, this is here. Let's say create the geometry first. Yes, अंसारी मुदस्सिर, आवाज क्लियर नहीं है. Okay, is it clear now? Is everyone facing the same problem? Okay, somebody, your voice is clear. Okay. Sir. Okay, sir, modeling of the beam or truss member as a line element, is it same as modeling them as a 2D element or 3D element? Okay, yes, it is similar. As I already told you, कि whenever in the presentation I have told you that whenever you require okay, let me, yeah, for 1D element, one dimensional geometry में आप या 1D element, whenever you are considering 1D element, so the condition is, for 1D element, condition is the cross sectional, this cross sectional area, yeah, cross sectional dimension, width and height are very small in comparison to your length. Okay, your length is very large. Your length should be very large, very large in comparison to your width. Okay, if this condition satisfies your height, okay, this is your W and this is your height. If this condition is being satisfied, then you can assume or you can take one-dimensional elements. Okay, this is for one-dimensional elements. For 2D elements, for 2D elements, so in case of your truss problem or 1D problem, beam problem, you can consider 1D elements. 1D element, won't be sacrificing much accuracy. But for 2D elements, in case of 2D elements, the length and width are comparable. The length and width are of same magnitude. But length is much greater than height या thickness कह लीजिए या फिर width is much greater than your height. Okay, width is much greater than your height. And in 3D elements, for 3D your 3D element, you must have the condition length must be length and width and height are of comparable magnitude. Okay, comparable magnitude. Okay, height. All the three dimensions must be of comparable magnitude. I hope this has cleared something. Sorry, I lost the connection. Sorry for the interruption. So, where I was, yeah. So, okay. Now, have I opened the geometry? Yeah, I have opened the design modeler. So now I am going to do the same problem with the three-dimensional elements. So first of all, I am going to draw the 3D geometry. Okay. So what I have selected the units in millimeters, select the plane. Okay. Now I will be drawing the cross section. Okay. So first of all, let me turn on the grid. Yeah. Okay, that's good. Okay. You can adjust these things according to your convenience or your geometrical constraints. Now let me draw the 40 cross 40. Yeah, 40 cross 40. वैसे तो ये देखने से it is actually 40 cross 40, but for safety I am just checking the dimensions. Okay, yeah, it is 40 cross 40. I have generated the cross section. Now I am going to extrude this geometry. So click on to the extrude, select the sketch that we have made and apply it. Okay, now what length we want? it is 1000 mm. Okay, 1000 mm. 1000 mm length is there. Now, as I click on to the generate, it will extrude the cross section of the beam. Okay. Now it's a 3D one. It's a 3D one. Earlier we have taken the line element. We had drawn this using line element. And okay, our geometry part is complete. Let's go on to the where modeling part, where we will be defining our uh, boundary conditions, meshing, and other things. Yeah, no, what I have opened actually. Yeah, this is, yeah. So it is, now you can see it is a 3D mesh, 3D mesh. 3D geometry, and when I am going to do the meshing, it will create a 3D mesh. Let me generate the general mesh. Okay, again this has considered it as a line element, but I can change by going to the sizing. What was my last element size? 0.10 mm. So I am again putting the 10 mm size. So 0.01, sorry, 0.01 mm. Oh, meters. So it is 10 mm. Now I'm going to generate the mesh. Yeah. Now you can see as a 3D element, it has gone to divided the element, or it has created the 3D elements, 3D elements, 3D elements. Okay, you can see this, and you can further, if you want, you can further uh, go to the smaller elements. For the smaller elements also, you can go for the smaller elements also, but no need to go over there because it will take much more time. We are just here to show how these things works. If you want, you can go with the further smaller elements, but as per your requirement. Okay, now we have selected, we have done the meshing, and in this meshing, what sort of meshing is this? Can anyone tell? Huh? Is it structured or unstructured? Hmm? How does it look? Is it structured or unstructured? It looks structured. It looks structured. No, everything is very well defined, well organized in this meshing zone. So it looks structured. It is well structured mesh. It is well structured mesh. Okay. But it is automatically generated. We haven't done anything here. So coming to the boundary conditions. So I have to define this fixed end. Now can select this end and apply. I have fixed this end. I have fixed this end, and now I want to apply a load. I want to apply the load. Where I want to apply this load? I can apply this load on this face or on this edge, or at any particular point, Let's say if I want to apply my load over here. No selection. Okay. It is not detecting actually. So leave it. We can just apply my load on here, onto the here, and apply. I have applied the load on this face. You can have selected, you could have selected this edge also, this edge also, this edge also. So, okay. Now I have to give the load in the component form. Again, what will be the load? Yeah, it is going to act downwards. This time, let's say minus y direction. So minus 1000 Newton, 1000 Newton. So my load is has been applied, and its direction, yeah, its direction you can see it is shown here. It is shown here. You can the arrow of the force is showing downwards. Arrow of the force is showing downwards. So, okay. Now, what in my results I want? What in my results I want? So, first of all, I want to see the deformation. It can be directional or it can be total deformation. So, for now, I am selecting the total. If you want to see the deflection in particular direction, let's say X, Y, or Z, you can go to the directional option also. I want to look at the stresses in the geometry uh, in my beam. So there are many options. There are many options. What sort of stress you want to look at? There are many options. Equivalent one MICS, maximum principal, minimum principal, maximum shear. So I'm just going for the select any one. What you require to look at, what you require to look at, you can select a particular one of those. So I'm just selecting the one MICS stress. Now just go on to, if you want some other results, you can also add this to your solution. Add this to your solution. Okay, but for time being, it's more than enough. Later you can find it. You can apply as many results as you want. So let's go and solve it. Let's go and solve it, and then we will see the डिफरेंस इन बिटवीन इन दोनों में डिफरेंस हमें देखने को मिलेगा. So you can see there is not much difference actually. If you see, this is the 3D portion. In this three-dimensional figure, if you see, the maximum deflection that we are getting is, the maximum deflection is again 7.8 mm. And if you see our earlier case, when we had uh, when we had the line geometry, then in that case also our deflection was what, 7.8 mm. It was closer to 7.8 mm. So there is not much difference if you do in this way. Okay, you can, if your system allows you to model it as line element, you should go with that, because in doing that, if you are going with the line element, your system will be lighter, no? The analysis will be simpler. You might lose some accuracy because you might not be getting exact result. Let's say you won't be 100% accurate, but at least you will be 96-97% accurate. Okay, so that much of accuracy is sufficient to go on with, because when you compare it with this time saving and cost saving, then there it will this thing matter much. Okay, the cost and the time related with these things matters a lot. Okay, so here you can see this thing. You could have apply different loads, okay, different boundary conditions onto these, and different types of load. You can apply line load, you can apply the uniformly distributed load, you can apply the point load at the middle, you can have the simply supported beam, or you can have the fixed at both the ends. So you can have fixed beam also. You can have the case of the fixed beam also. Okay, so this is what we have done till now. So I hope things are somewhat clear to all of you. This is okay, structured. Okay, yeah. ठीक है. Okay, now we are going to proceed to the next problem that we are going to do, and this problem is of this. Is it visible to everyone?
Yes, sir.
So, first of all, we are going to solve this truss problem. This truss problem. So, before solving this, we have to what? First of all, we have to create this truss. Okay. So, we are going to do it in uh, we are going to treat it as a line element only. Line element की तरह ही treat करेंगे. We are going to treat this as line element. Okay, as we had done the in the first case. जैसे हमने पहले केस में किया था वैसे ही हम लोग यहाँ पर भी करेंगे. So let okay. Before we proceed for the next example, if any one of you having any doubt, you can ask, or anything that you haven't got means you haven't understood while in this example, you can ask. No, everything you got clearly. Okay. Okay, let's start with the. Let me close some tabs. This one, this one. Also this one. No. Again, select the static structural. Material by default we are going to use structural steel only, and now just go on to geometry. Sorry, let design modeler to be open, and okay, here we have the design modeler. Let me put this onto the right side, and onto the left. So it will be easy for us to draw. Yeah. So I hope this might be visible to all of you. And let's go here and try to, first of all, let's see what is the unit here given. Unit here is given in meters. So, but in meters, we might face some problem. So I'm again converting this to the mm. mm, let's say it should be to okay. Let's keep it in only. Mm में ही रखते हैं. Now look onto the plane, XY plane. Turn on the grids. My major spacing is 10 Let it keep 10 mm. Now we will start from this section. This section. So how much it is? Yeah, hide it. Select line. First line, it is 0.2 meters and 0.25 meters. That means 0.45 meters in horizontal direction. So in millimeters, it is how much? 450. 450. So 450. So this is okay. Let's create it. Let me change the unit first. Keep it in centimeters. Okay. Now this is good. Okay. This is much better. Much better. Let's go on to draw. Draw a line of 45 centimeters. So okay, dimension it. How much it is? Journal dimension 45. Enter. Now I have this line. From this line, go on to the vertical. Draw a line and go on to the vertical. How much? 0.2. That means 20 mm. Or 20 centimeter. 20 centimeter. And leave it. Okay. Then into the horizontal, and it is 0.25 meters. That is 25 centimeters. So click it and drop it down. From here you can see this is your this line, and okay, it has been created. Now you can just carry on the upper part. From here you just have select the line command. From here it is 0.25. So let's say leave it here and dimension it. Dimension it. How much it is? 25. Enter. No. Okay. Draw the line. It is going from here to here. Okay. Then a line from here. Okay. No, from here to the 25 centimeters. Yeah, 25. And a line joining this is here. So again, you have one more line. One more line. What is this? One more line. Sorry. Yeah. It is vertically 25, and this is it. This is it. So Here's how you create. Again, go on to line. It is 25, so it will again be 25. Join it and just keep on drawing a line.
थोड़ी देर बाद आएंगे, थोड़ी देर बाद आएंगे, थोड़ी देर बाद आएंगे।
अभी तो अभी भी नहीं दे पाऊंगा। ठीक है, 4 के बाद from here you have this thing. How much it is? Yeah. Yes. It is. Now you have we have created the sketch. You can do what in whatever way you like. Now we have created this sketch. Let's go on to generate. Let's go on and generate the sketch. Okay, the sketch has been generated. Sketch is generated. So now what we do is we define the cross section. We define the cross section. Go onto the concepts and select cross section, and the cross section is rectangular cross section. So rectangular cross section में हमारे पास जो डायमेंशन है वो 5x5 की हैं. 5x5 mm, दैट मीन 0.5 centimeters. 0.5 centimeters. Enter. Now we have the cross section. Now you select, go on to the again concept and select lines from the sketches. Lines from the sketches. When you select the line from the sketches, select the sketch and apply the object. So click on to the generate. Now you have a line body generated here. Okay, generated. Line body is generated, but you haven't defined the cross section. You haven't defined. You haven't defined the cross section yet. Okay, so we have now assigned the cross section here, and the geometry is complete. Okay, you select, click onto the line body. Now where is the cross section? We can go and have a view of it. Let's click onto this, and when you click onto this, you can see that now you can see the yellow line is encircled by or enclosed by some solid part. Okay, some solid part. It is being shown. Okay, so just you can now see in much better way. Okay. Yeah, this is much clearer. You can see now the joints also. Even let me, now you can see. Let's say this is the joint. So the dimension was in rectangular cross section tha. It was rectangular cross section. So you can visualize the joints and the whole truss. The whole truss you can see. Now we have the geometry created. Now what we have to do? We have to go on to the modeling part. Modeling part. Modeling part. Modeling part. So no, it hasn't. Okay, we have selected the different. Oh yeah, sorry. Yeah, this one. So click onto the model and you can see. You can see. This is showing here. Okay, the line body is being shown here. So first of all, only lines are shown. So first we turn on the cross section, turn on the view of the cross section. Now it is much more clearer to all of you. So it is looking like this, somewhat like this. You can see, even you can see the gappings that has occurred due to joining of the rectangular cross section. Okay, so what we gonna do is alt tab, snap right, alt tab, ठीक. तो अब हमारे पास ये चीज आ गई है. We have now this. Now we have to apply the loads and the boundary condition. Apply the loads and the boundary conditions. So boundary conditions are that this is fixed at this point. You can see my cursor, and at this point, at the bottom points, both the bottom points, the structure is fixed. The structure is fixed. Okay, the structure is fixed at this point and at this point. So first of all, we haven't created what nobody told me, that we haven't created the mesh yet. We haven't created the mesh yet. So okay, now what is this? Yeah, so let's see. mesh तो अभी हमने create ही नहीं किया, तो let's generate the mesh. Generate कर दीजिए. Generate the mesh. It will be generating the coarse mesh. Coarse mesh. You can see the individual elements of this single element. Oh, single element 1, 2, yeah. These are the elements. So if you want to reduce the size of these elements, as usual, by default, you can go on to 10 mm, 0.01 meters. So now if you go and click onto the generate mesh, so now this time you have much finer mesh created. Okay, this one, like this. So like this. So you can see the elements that has been created in here. Now, what we do is we have the meshed part. Now we have to define the boundary conditions. So first of all, fixed supports हैं. So fixed supports कहाँ हैं? At this point. So it will be detecting only points. So select these 2 points and apply. So we have selected, or we have defined the fixed supports. Now we have to apply the loads. So select the load. What type of load? कहाँ पे लगाना है? तो in our particular case, all the loads are of equal magnitude. So just select this point. You just wanted to apply components. So it is in negative y direction. So minus 1000 Newton. Okay. One load has been applied here. Similarly, apply one more load, and where you just want to apply a load in here in a component form. Again, this is minus 1000 Newton. Now again apply one more load at the top, and it is also 1000 Newton. 1000. No, we haven't changed it to components. So minus 1000 Newton. Okay. Yeah, this is now. Again apply the load here. Component form minus 1000. Then you just click on to the apply load. कहाँ लगाना चाह रहे हैं भाई? यहाँ पर. Yes. Just change it to component form and just click on to the minus 1000 Newton in the y direction. Now all the loads have been applied. Onto this frame. Now what results you want? Basically in this type of problem we generally want the deformation. So we have selected the deformation and we can now solve it. You can see this. All the loads and the fixed boundary conditions are here. The points A, B, C, D, E, F are showing the force, fixed support. So this A point is just not only here, but it also includes this point. Because if you see, we had selected two vertices. Okay, now we can solve this and we will get the result. Wait. Okay, we have the solution here with us. You can see whenever there is green tick, that means our everything is very correct. Okay, and if you see anything apart from this green tick, that means there is something that requires some attention. Okay, either the solution maybe cannot be done, or there is a need of refresh or something else. Okay, so you can see this, your truss has deformed like this. And the maximum deflection that you are getting is of 0.6 mm. But in the figure you can see that it is deflecting too much, more than 1 mm it is deflecting here, but it is due to your scaling, auto scaling की वजह से हो रहा है. It is due to auto scaling. If you click on to the true scale, 1:1 का scale, अब अगर आप deformation पे देखेंगे, 1:1 scale for deformation is, you can see your deformation is not much. Okay, you can see just results, because the maximum deflection you are getting is 0.67 mm. 0.67 mm. That is not much. It is bearable, or it is acceptable. सो हाँ बताइए. ओके. सो आई होप इसमें थोड़ी चीज़ें समझ में आई होंगी आपको. यू माइट हैव गॉट समथिंग टू understand that what are the things that you can do in this software using this software. The simulation you can do with this software, and the time is limited actually. Okay, so uh, I cannot teach each and everything in one or two lectures. Okay, this requires a lot of time to get on because the before starting this software alone, you might have to go through a lot of theoretical portions first. theoretical portions से आपको बहुत ज़्यादा पढ़ना पड़ेगा. In that, the basic requirement is of finite element analysis of finite element methods is already a subject that you have to have a command on which you have to have some command, good command on finite element methods. Hmm. And then your foundational subjects in your mechanical engineering or whichever branch you belong or whichever field you belong, you must have the foundational knowledge of that subject. Okay. For example, for a fluid engineer or thermal engineer, you must know the thermodynamics and fluid mechanics first. So I am leaving it here, and I welcome some queries from your side. Queries from your side is welcome. So if you have any question or any queries, you can ask by turning on your microphones, or you just can type in the chat box. Okay, yeah. A good question. How do the Miss Debdi she's asking, how do we include connections like bolt rivets when simulating? Okay, truss. Okay, listen. You cannot do this thing when you are doing it with the line element. Okay, when you are doing it with line element, you cannot go with the bolt or joints. Okay, you cannot go with the bolts or joints. Okay, but suppose you have made this structure in 3D. Suppose you have made this structure in 3D. 3D. I will show you the example of that in my lifting lug problem. Lifting lug problem. I can show you. It provides you the option. Okay, so what you have to do is you have to create different 3D components, different 3D components, and then ANSYS provides you the option to define the joints. For example, this lifting lug, this is a lifting lug. Okay, uh, it has two bodies, the first one, the upper part, and the base. Okay, so uh, these are two bodies, and there must be some joint. Okay, I have separated them. They are separate bodies, but they are connected with each other with some joint. In ANSYS, you can see, if you are have different bodies in connected with each other, you can see here is an option of connections. Here is an option of connections, and in connections you have contacts. So by default, this is the contact. If you click onto the contacts, you can see it has a target body and it has a ऑब्जेक्टिव बॉडी और कॉन्टैक्ट बॉडी, ठीक है. सो इट इज शोइंग यू द कॉन्टैक्ट बॉडी जिसपे आपको कॉन्टैक्ट हो रहा है. दिस वन इज द कॉन्टैक्ट बॉडी इट हैज कंसीडर्ड, एंड दिस वन योर लग अपर पार्ट इज योर target body, and by default it has treated it as bonded type. But if you just want to change it to some other type of connections, here are the options. You can see it in the definitions. Let me make it more clear. Here you can see it by default, if you are having two bodies in contact with each other, it will by default, ANSYS will by default consider it as your bonded type, that there is some adhesive bond and it has been joined, these two bodies are joined together with some adhesives. But you can change it from here. No separation, frictionless, rough, frictional, or this type of bonds. So when your question was how to show the bolts or rivets when we are simulating this. So you have to create the bolts. First of all, you have to make it in 3D. And while making the geometry, you have to go with the you have to create those rivets and the bolts also. If you are using rivets, then you have to create the bolts or rivets also. And if you are you are joining those components with the bolts, then you have to go with the bolts also. Bolts, you have to create the bolts in the geometry itself. And depending upon that आपका situation कैसा है, you can use the type of bonding between the bolts or rivets along with the truss and the rivets के बीच में joint कैसा है. Is it the bonding type or frictional type or non-bonding type? Okay, so by this you can select the you can define the joints or connections. I hope this might have cleared your doubt. Okay, anything else? Any query that you haven't got? No?
Sir, any question and to solve the, sir?
Yeah.
Any question to solve you?
Please, you can. You are free to speak in Hindi also. No issue. Or you can type. Yes, Shahbaz. You can
Okay,
type
sir.
either.
Yes, sir. Yes, sir.
There is some query or some students, so I might be. Okay. So I suggest. Yes, Mr. Ansari Shahbaz, you were to ask something.
Sir, any question you solve, sir?
you are asking that can we solve any type of question on ANSYS? Is this your question?
In mechanics, sir. Mechanics.
Yeah.
Mechanics first. In
Yes.
ANSYS.
Yes, for sure. It can solve almost all the problems related to your mechanics. You can use this. It has different
Sir.
modules. Na?
Sir.
You can see all these modules are here. So using these modules, you can
Okay,
have
sir.
some solve your problems. Even the complex problems. Okay, suppose these modules are not allowing you to do or solve the problems that are some much more complex. Okay, so you can go on to this part here. This is mechanical Apdl. Okay, so this allows you to code your problem in the ANSYS, and that is much
Okay.
way a very easy way to solve your mechanical related problems. Okay, you can solve all the problems. Yeah, more or less,
Okay,
it
sir.
is majority of the problems you can solve using your ANSYS